Go.
Hi everyone, myself I'm Hari Krishna and my teammate Anusha. We did our capstone project on predicting false information about crime using supervised machine learning. Fake news can be defined as a set of elaborate lies or hoaxes that are deliberately fabricated to mislead a person or the entire community. With the current available social media networking sites like Twitter, LinkedIn, and other platforms, it's very easy to spread the false news and to reach millions of people in a few seconds. So, in the recent years, we see that fake news has led to several civic unrest and healthcare threats to national security, cyberbullying, public shaming, and in very rare cases, we also see it may lead to wrongful convictions. So, given these danger nature of false information, so it is quite important to identify the false information at the very early stage and to stop spreading by removing the information from the networking sites or the social media platforms. So based on that, we started our work, and here is our hypothesis question. Can we determine if the given information about crime is true or false? Are the platforms where the statements were made and the labels are dependent? Are the sources of information and labels are dependent? And also we wanted to see if the negative sentiment and the label were dependent or correlated. And we wanted to check what's the average time that's being taken by the investigators to manually validate if the given statement is true or false. And we also wanted to see if the traditional machine learning algorithms can perform better than deep learning algorithms. So for this project, we took the data from polityfact.com by scraping that website. PolityFact is an American nonprofit project and it's being operated by Poynter Institute in St. Petersburg, Florida. It's a reliable source of information where the statements are manually evaluated by the editor journalists and they assign the ratings that may range from true, false, mostly true, pants on fire, like that. So we are scraping the data, mainly focusing on three categories, that is crime, guns, and marijuana. So here is our proposed model architecture. So in the first page, we are collecting the data by scraping the PolityFact website, and then we are cleaning the data to see uh, and derive the insights from the data and convert it into suitable forms like vectors to train the models. And we did the exploratory data analysis to visualize the trends in the data set. And then we did sentiment analysis using Python inbuilt libraries like Vader and hypothesis testing. And for future extraction, we have used national natural language processing methodologies like TF-IDF and bag of words to convert the text data into vector form. And later for prediction, we have used different traditional machine learning models and deep learning models. And here is the data frame that looks after scraping the data from the website. So basically we are collecting the statement and the link and the date, source, and the context, and the message content, and the label which is given by the PolityFact. So here is the data frame after cleaning the data set. So if we see, we have a few more columns. So basically we are parsing the statement and a few other columns to get the fact checker and the date the statement has been verified by the PolityFact editor, and the date the statement has been stated on the platform and the stated platform. So for EDA analysis, we have used Python inbuilt library called Vader to see the sentiment affects the labels or not. And the labels that are given by the PolityFacts are different ratings like true, false, mostly true, half true, pants on fire, barely true, like that. But for our model, we have converted the barely true, pants on fire, and the false labels to false, and the half true and the mostly true are converted to true. Basically, we want to build our model using a binary classification. So here is our label distribution. Well, if we see that we have 53% of true information and 47% of for fake information, so it seems the data is quite balanced. And after sentiment analysis, if we see that 84% of the statements are negative and 16% are positive statements. And it's the sentiment label counts. So if we see in both true and the false information, the negative counts are high in number compared to the positive sentiment. So here are the top 10 information sources where the statements have been made. The anonymous Facebook posts are the top, and the viral image, it seems it's the second in the top information sources. And it's the top 10 sources of information. So it seems that Hillary Clinton is the top originator of the statements. And next, it seems Donald Trump and the anonymous Facebook posts are the top 10 sources of true information. And again, the top 10 sources for false information is anonymous Facebook posts. And we wanted to see what are the top 10 platforms that the statements have been made. And it seems that interview and the social media are the top two platforms where the statements have been made. And the top 10 platforms for spreading misinformation is social media and the interview. And again, the top 10 platforms for the true information is interview. Anusha, could you please take over from here?
Yeah, thanks, Hare Krishna. So the top 10 fact checkers for our data set are Tom Kirshner, followed by W. Gardner Shelby. Then the amount of misinformation throughout the years, I mean, the number of articles that had false news, we could see it was highest in the year 2020. There were very huge number of false information that was being spread, followed by the year 2018 and the year 2022. Then distribution of true information, I mean, the number of articles that were true or had some factual information. So it was highest in the year 2016, followed by the year 2013, and then followed by the year 2015. So we did perform some statistical analysis as well to check if there is a dependency between the source and the label. So does the originator of the information contribute or influence the label that the article will get or not? So we perform chi-square analysis because both of these variables are categorical variables, and we get a p-value that is less than 0.05. So we reject the null hypothesis and we accept the alternate hypothesis that the originator or the source of the information as well as the labels are dependent. Then we check the dependency of the platform on which the statements were made and the labels. So our null hypothesis will be to assume is that both the label and the platform where the information were made are independent. That means the platform does not influence the label, and our alternate hypothesis will be that they are both dependent. So after performing a chi-square analysis, we get a value we get a p-value which is less than 0.05. So we reject the null hypothesis and accept the alternate hypothesis, stating that the label and the platform where the information was posted are independent. So we perform one more test where we check if the negative sentiment does it have any effect on the label. So our null hypothesis is that the label and the negative sentiment are independent, and our alternate hypothesis is that the label and the negative sentiment are dependent. So again, we perform chi-square test on this, and we get a p-value which is greater than 0.05. So we fail to reject the null hypothesis. So we do accept the null hypothesis that the label and the negative sentiment are independent. And so these were few statistics from our data. So the average time that is required to fact check the information is 17.4 days. So for so how much time? So we are checking per label as well. So for true information, the amount of time required to validate true information is 16.73 days, and for false information it is 17.99 days, so almost 18 days. So these are we use word cloud to find out the most frequent words that are associated with false labels and most frequent words that are associated with true label. Then for a feature extraction for traditional machine learning models. So our machine learning models, they cannot take the text data. So they need some sort of transformation. So first we remove if there are any alphanumeric as well as numeric characters from the text. Then we have the X variable and Y variable. Some modern training data set will be the articles, and so our X model training data set will be our information and the articles, and our model testing will be the labels. So we split it into training and testing data set. Then we use count vectorizer on the data sets on the training and testing data sets to convert the text into vectors, and that is on the basis of the frequency of the word. Then we use TF-IDF transformation to make sure that the representation of these vectors is meaningful. For our deep learning algorithm, for our deep learning models, we use a different approach. So splitting into X and Y variables as well as test and training data sets is similar. So instead of using count vectorizer, we use tokenizer to tokenize the data. And we use pad sequences function to make sure that the sequences or the sentences that we provide to our models are of same length. And then we convert the labels into categorical values, that is one hot vector encoding. Then our first model is our naive-based classification model. So this is one of the most common models for natural language processing and text classification. So we get a precision of 71% for the false label and precision of 74% for our true label, which is fine. Then we use our support vector machine with grid search. So our precision slightly increases in this case. So for our false label, it gave a precision of 74%, whereas for our true label, it gave a precision of 76%. Then for our logistic regression model, the precision was 73% for the false label and 75% for the true label. So the last model that we did was XG Boost. So for our XG Boost model, we got a precision of 85% for the false label and 84% for the true label. And we used two deep learning models. One is bidirectional LSTM and GRU classifier. So when it comes to our bidirectional LSTM model, we get a precision of 66% for a false label and 71% for true label. Whereas for our GRU model, we get a precision of 61% for false label and 60% for true label. So we tabulated all our results from all the classifiers that we have developed, and we could see that our XG Boost model performed with grid search performed the better with accuracy of 82% and a precision of 82%. And we then finalize this model and we deploy it. So we use Pickle to save this model. So we take the data, we take some other data which the model has not seen before, and then we put all the vectorizing, we put all the vectorizers as well as boosting in one function, and we check what is the class of this particular statement. As we can see, our model has predicted that it's a false information. Then these are the answers to our research questions, the ones which we were told which we asked in the beginning of our experiment. So the question about if we can determine whether the information is true or not. So we were able to determine it, and we can say that we were able to determine it with an accuracy of 82%. And so we also know that the labels as well as the platforms where these information was made or the statements were made, they are dependent. And when it comes to the, if the originators of the information as well as the labels are dependent or not, we can say we could see that yeah, they are dependent. And if the negative sentiment has any effect on the label or not, we were not able to determine there is an, if there is any relationship. So we assume, so we can say that they are independent. And the average time that is required to check if the statement is true or false manually was around 17.4 days. And where the answer is, if to the question that if traditional machine learning models perform better than deep learning models, we can say that yes, traditional machine learning models do perform better than deep learning models. So future scope, so how can we use this project is we can integrate it with any social media platform. So social media platform or any independent, or this itself can be developed as an independent website where you can validate if the information is true or false. So when it comes to social media, when if we integrate it with social media, then we can, you know, either flag that information as false information and inform the users that hey, you know, the information that you have posted is false, so either you take it down or you so that either you take it down or just be aware that this is a false information. Then the model that we are then the model, since our deep learning models, they do not perform better than our traditional machine learning models, we can add more data sets. We can, you know, include more categories, and we can expand the data set to make sure that they perform better, so that they have more information to learn from. And we since we constructed this data set from scratch, we think that others can be benefited from our data set, and they can use this data set to build their own model, so they don't have to start the procedure of extracting the data from beginning. It's just they can improve on our models. And also we can use attention mechanisms as well as word embeddings to further increase the accuracy of the model. And limitations is, like we said, we worked with 2000 just 2000 rows. So if we have a larger data set, if we have more categories, if we have more number of rows from which our models can learn, then yeah, the accuracy can improve. And also the initial problem or initial labels were multi-label. So since we have converted that multi-class classification problem into binary class classification, so we might have lost some information. And also we have trained our model on crime specific data sets. So if we are testing this for some other category like entertainment or sports, we need further training to make sure that our model is equipped to deal with those topics as well. And also we do require little sophisticated pre-processing algorithms, as we discussed, like attention mechanisms, BERT encoding and all that, to make sure that we are extracting the right features. And conclusion, so what we have achieved in this project is we built our data set from a reliable source, and we built it from scratch. Also, we used sentiment analysis, which we didn't find it any of the papers that we read for our research. So we were the first ones to check if there is any impact of the sentiment on the labels. Unfortunately, we were not able to determine the relationship between sentiment and the label, but this is something which we tried. And also we used different classification algorithms to check if the information is true or false. And our XGBoost classifier has an accuracy of 82%. So we selected this as a panel model. And also, as per our data set, we could see that the average number of days that is required to manually check and assign a label was 17.4 days. But our model was able to perform all of this in just a matter of few seconds. So just in a matter of few seconds, you'll be able to know whether the statement is true or false. So that is saving a lot of time. So, if you are able to implement in real life, if you are able to implement it in social media platforms, and yeah, within seconds they'll be able to tell if this uh, post is correct or not, and they'll be able to take down this post, or they'll be able to flag this post, so that not a lot of so that at least the damage that it could do can be reduced. So anyone who is seeing that post, they will know that it is not a true information, it's not a reliable information, so they won't believe it. So this is one way where we can stop the spread of misinformation. And these are the set of our individual contributions. This is my contribution, as this is Hari's contribution. And these are the references that we use to build this particular model and this particular data set. And thank you for your time.